everybody. Welcome back to Environmental Science Analysis with Dr. Lisa. Today is the first video that I personally am going to make that's about R that I think you're going to watch. I know you've watched a couple of other videos about how to use R, but I think that this is the first one that I've made that you're going to watch. So I'm going to go through this, try to do it real slow, real simple. So we're going to just do a multiple linear regression in R. Okay, so here's R. It's scary. Okay, so one of the things that I've learned about R is when you want to get rid of all this crap, you just hit the little broom icon, and it goes away. Yay! I'm going to do that same thing up here. You want to be careful about clearing objects from up here, because you might need these. So be careful. When you clear the console, that's not going to kill you. If you just want to remove specific stuff from up here, you could hit the broom and sweep everything from here. If you just want to get rid of one thing at a time, you could just say remove PFAS, for example. And since I'm in the console, I only have to hit enter. I don't have to hit control enter. And look, PFAS is gone. So just to tidy things up a bit, I'm just going to remove that stuff. Okay. Enter. There we go. So nice and clean. Good to always start with a blank canvas. Okay, so we're going to use R. And I always start with some code, use the little hashtag symbol to say, okay, what the heck is this? It's a multiple linear regression in R. The next thing we do is we always load up our libraries. And, again, we use these little hashtag annotation lines. These are lines of code that are not run. They're just there. It's just text to help you. They serve as guideposts. And it's a good place to put things that you might want to use later, but you're not using right now. So later on, I might want to load up this library for ggplot2, in which case I could just delete the little hashtag symbol, and now that's live code again, and I could run it. Control Enter, or hit the little run button, either one, and you can see it loaded up. Loaded up the library called ggplot. If I go over here to Packages and I scroll down, ggplot should be, right? ggplot should be now. Well, it should be loaded here. It should have a little click mark. I don't know why it doesn't. Okay, so anyway, first thing you do is you always load up your packages. Whatever packages you're going to need to run this code. So there I go. I just ran a bunch, loaded up some packages. And the next thing typically you're going to do is load up your data. So real simple, you give your data a name. In this case, I'm just going to call it PFAS. That's for perfluoroalkyl substances. Use the little arrow symbol here, the less than, and the little dash here. This is basically feeding in, it's an arrow feeding into this thing I'm calling PFAS, a CSV file, a comma separated value file. So I'm using the command read CSV, and then I'm using the pathway here, and notice that it's in quotation marks. We have a parentheses, and then the quotation marks, and then the pathway and the name of the file. And then notice I'm saying header equals true, because in this CSV file, the first line, the first row, are my headers. And so I want it to know that. So again, Control Enter, and suddenly PFAS appears over here, and I could double click on it, and I could actually see the data. So here's the data. This is the same data that I used in the video where I did the linear regression in Excel, and I used LineEst, and I showed you how to determine the significance using LineEst. Okay, so same data. Okay, so there's my data. Now, I'm going to make a multiple linear regression. So here's my line of code to do that. I'm just using this thing that's called LM, linear model. Easiest thing in the world, right? Parentheses here, and then what data am I using? Well, I'm using the data called PFAS. And then here's Y, and then the tilde here is like an equal sign, and here's all of my different X's. Sorry, I always do that. Here's all my different X's, okay? So I'm being a little bit tricky here because for my Y's and my X's here, you can see sum of PCBs, PCB ratio, sum of BDEs, etc. What I'm doing is I'm using the field names, the headers. So here's they are, sum of PCBs, PCB ratio, sum of BDEs. I'm using the names here in my code. And notice I don't have to say A times sum of PCBs plus B times PCB ratio plus C times anything. I don't have to put the coefficients explicit at the end there if I'm using the function linear model LM. Okay, so it's really very simple. So for these X's, I'm just using the column headers, the names. But for the y, I'm being a little bit tricky, and I'm saying the data table called PFAS and whatever's in column number I. Okay, and I've specified up here that I is number 12, just to get us started. And I'm doing that so that if I want to change it, I can. All I have to do is redefine what I is. And that's why you'll notice over here, I is defined as 12. And if I changed it, I could say I is 13, Control Enter, and booyah, all of a sudden, I is now 13. But let's go back to 12, because I know that will work. Control Enter. Okay, so here's my model. Again, call it anything. Call it Fred, doesn't matter. So here's your line of code, Control Enter, everything is fine. Remember, if something is wrong with your code, there'll be a little red dot over here, and if you hover over it, it will tell you roughly what's wrong, or at least it'll give you some clue of what's wrong. Okay, so that worked fine. I got no error messages. I'm happy. Now I could summarize this. Give me a summary of what I just got from the model. And here's your summary. Okay, intercepts, coefficients, yada, yada, yada. It tells you what the linear model was. It also gives you some residuals, coefficients, standard error, t-value, p, significance codes, degrees of freedom, a bunch of useful stuff here. R squared, adjusted R squared. Adjusted R squared is adjusted for the number of data points. Here's the F statistic and a bunch of other stuff, okay? Now, if you were paying attention and you watched that video that I made about doing all of this, basically exactly the same thing, but doing it in line est, I can say, just highlight this and say Control-C to copy it. And I can go over to my Excel here. So here's my output that I was doing in that other video. This is the linear regression that I did using the data analysis regression thing. And then down here I did the same thing using line est. Okay, so I just copied what I got from R. Control-V will paste. Notice, if I click on this, this line contains all of the text. And maybe I don't want that, so I could say data, text 2 columns, delimited, and I'm going to guess that this is space delimited. That's what it looks like. If I hit space delimited, it shows me where it's going to put the breaks. Looks good to me. I hit finish, I'm good to go. So here's my data. Now it's in its own cells. But the point is, look at these values, 82.75, 82.75, minus 0.1357, minus 0.01357. The point is, the coefficients are exactly the same, standard error is exactly the same, the absolute error, it's using the space between standard and error and dividing it up that way. That was actually my bad. But this is the t-stat, and then here's the p-value. And even the p-value is exactly the same. If I give myself one more decimal place here, you'll see that that's exactly the same. 9.83 times 10 to the minus 4. So we get exactly the same results. Rest easy. R is not doing anything it shouldn't be doing. Okay, so we did a multiple linear regression, and now I just summarized it. Well, maybe I would like to send that output to a file. So I might use this command, write CSV file. What do I want to put into it? I want to put this thing that I called model. And the file, I'm going to give it a file name. I'm just going to call it output.csv because I'm not very creative. So Control Enter, and it says, nope, error as in data frame, default, optional, whatever. Cannot coerce class linear model into a data frame. Oh, well, that sucks. So actually, it turns out there is a way to coerce linear model into a data frame, and it's this wonderful thing called tidy. And it comes from a package called tidyr, tidier. And if I just type the command tidy model, Control Enter, nope, that's because I didn't load my tidy package. There we go. Now if I do tidyr, why can't it find the function tidyr? Sorry about that. Turns out I need to actually load this thing called broom as well. Load package broom. Control Enter, and then I can write tidy model. Enter, and it gives me my table. And notice it's awfully similar, right? Let's run both of these right next to each other so you can see even better. Okay, so there's the two tables. This is the summary table, and then this is the tidy table, right? But the difference is that if I go in here and say, write to the CSV file summary of model, and Control Enter, I get, again, the same error message. You cannot coerce this linear model into a data frame. But if I say tidy up the model, Control Enter, booyah, no? Oh, I know. The problem is that it already exists. See, I practiced all this. I practiced it very, very carefully so that I wouldn't screw it up. And here we are. So, see, I already created this output file. Let me delete it. Sorry. Delete it. It's because it's open in Excel. Yeah. You know, we are experiencing technical difficulties. Now let's go back here. Try again. Okay, now it's gone. And now, in theory, I go back to R. Let's try it again. See, we all make mistakes. Control, Enter, booyah. Okay, now I have no warnings, no mistakes that I've made. And notice I told it not only what to call it, I called it output.csv, but I also told it where to put it. Put it in my directory called rcode. So if I go to rcode, which is here, there it has now been created. You see it was created at 2:19 p.m. and it is indeed 2:19 p.m. So this is the new version. Double click on it. And wait a second. And there it is. Voila! It's like magic! I was able to do a multiple linear regression and I was able to output the data to a CSV file. And I think that's pretty freaking cool. I'm just getting started with R. I'm just figuring it out, and I think the fact that I got through this with only minor technical difficulties is pretty impressive. I hope you're proud of me. Okay, so that, you know, it's good. It's good to show you the kind of things that could go wrong. And now I could go back here and I could change my data column. Right now I'm looking at column 12, which is over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the sum of measured concentrations. If I say 13, it'll be PFAS. So I can just go in here and say, do number 13, Control Enter. Run this again. I'm not going to try to create the data file because it'll tell me it already exists and give me an error message. But again, you can see I can get my output. So just by changing one number over here, I was able to do another file, another regression. And in a later video, there's a video I already made that's about doing stepwise regression, and it will show you how to loop through many columns of data. It actually uses a data file, not exactly the same, but very similar to this. This is ranked data, and it uses the concentration data, but either way, it loops through all of these columns of data and does a stepwise regression. So you can look at that video if you want to know how to loop things. But there you go. Very quick, easy introduction to do something very simple in R.